Hello everyone. So till now we have seen the different types of welding and different types of welding techniques. Okay, which here we will see in one glance. So here we have seen initially the welding process, the definition of it, the safety equipment which uses during welding process. So the classification of welding process, fusion welding, non-fusion, and these all types we have seen. Okay, so we have also seen the in gas welding, oxyacetylene welding. In arc welding, we have seen the submerged arc welding, and also in distance welding, we have seen the butt welding, spot welding, projection welding. So today we are going to say about the soldering, brazing, and braze welding. Okay, so this we have seen fusion welding process, non-fusion welding process, gas welding process, arc welding process, different component uses in welding, gas welding, oxyacetylene gas welding, types of flame, its description, torch angle, welding technique, that is forward, backward welding technique we have seen. We also seen the arc welding, its working principle, TIG welding, MIG welding, submerged arc welding. We have seen also the resistance welding, spot welding, then seam welding, then precision welding. Till here we have seen the different weldings. Okay, so today before going to the soldering and brazing, let us see one small bit, that is the inspection of welds. Okay, so here whatever the weld is there, it has different inspection method. Okay, and out of the many inspection, first one is a visual inspection. Visual inspection means human operator visually examines the weldment. He checks he checks the different parameters, that is the dimensions, that is confirm the dimensions, warpage, cracks, cavities, incomplete vision, etc. And these supervisions can be made by a human operator. That is if is there any crack is there, or is there any cavity is there, or is there any incomplete vision is there. This visual inspection can be performed by a human operator. Okay, but it has some limitations for the visual inspection, because whatever the internal defects are there, these defects cannot be detected by the visual inspection. Okay, so this is the limitation of visual inspection. Now the second one, that is the non-destructive testing. Non-destructive testing is that means, yeah, there is no any destruction of the material is not there while checking. Okay, so this what happens, there are two tests are there, that is dye penetration test and fluorescent penetration test. These are used to detect the cracks and cavities that are open to surface. Okay, and along with that, internal cracks, cavities, and flaws are detected by using a radiographic and ultrasonic technique, which is these are known as a non-destructive testing. And last one, that is the destructive testing. So here what happens, whatever the weld is there, that weld is destroyed in testing, and mechanical test is done for the tension, compression, shear, which is performed on the weld joint. Okay, so whatever the metallurgical tests are, metallurgical test for microstructure defects, heat affected zone, etc., are performed on the welded joint. Okay, so these are the three inspection methods are there. Now let us see the next, soldering. Okay, so as we have seen that all welding techniques reviewed so far involve partial melting of base metal to form a homogeneous bond. Okay, but in soldering and brazing process, a joint is formed without melting, without melting, uh, without melting a base metal. to form a homogeneous bond. Okay, so in soldering and in brazing, what happens here? A joint is formed without a melting of a base metal. Okay, so both techniques have certain similarities there. Okay, so in soldering and brazing, the joint is filled by a liquid filler material. Okay, and on solidification, the filler creates a bond. Okay, so the melting temperature of the filler is much lower than the base metal. Hence, the process soldering or reducing temperature, there is no melting of the base metal is there. So, water soldering is there. If you see the soldering is a lower temperature process. The melting temperature of the filler material is less than the 400 degrees Celsius. Okay, and brazing is there. Brazing is done at high temperature, and the melting temperature of filler is higher than 400 degrees Celsius, but lower than 900 degrees Celsius. Okay, so both process can be performed manually or can be highly automated to suit the production variety. So the bond is whatever the joint is soldering and the brazing is created by the filler material. Okay, which has a composition of which is generally quite different from the base metals, and it is having a melting temperature which is much lower than that of the base metal. Okay, so hence to obtain a strong joint, it is necessary that the filler completely spreads easily on the joint surface. Okay, so mm, there are some filler materials are there. Okay, so it has some properties, filler materials. Okay, that whatever the filler material is there, they should easily spread and wet the base metal surfaces. Okay, and if we see the brazing and soldering is extensively uses in electrical and electronics industries, and whatever the filler material is there, for that it should have a good electrical conductivity. Okay, and apart from that, the filler material is have a homogeneous structure and the melting point to suit the process, and also it is having a good formability to acquire a wire or sheet form. Okay, and last point, that as the filler has a composition different from the base, so it should not corrode the base metal by forming a galvanic couple. Okay, so it should, whatever the filler material is there, it should not corrode the base metal. Okay, so these are all the properties of the filler material, and the materials which are commonly used are copper base, silver base. If we see for brazing, copper base and silver base material uses, and for soldering, uh, different alloys uses like lead tin alloy, tin zinc alloy, lead tin antimony alloys, cadmium alloys, indium alloys. Okay, so such a different alloys uses, soldering as a filler material. Okay, so here you can see the soldering processes. Okay, so whatever the small job is there, for small job the soldering is done by a manually. Okay, by using an iron or a gas flame, normally uses the iron, and whatever the iron is there, it has a special tip which is which is made up of a iron coated copper, and the iron whatever the iron is there, it is it it is heated by two ways, either on a stove or by an electric heater. Okay, and then flux and solder are applied separately. This method of soldering is extensively used in electronic circuit fabrication. Okay, this soldering process normally uses mostly uses in uh, electronic circuit fabrication. Okay, So various types of tips are available for different jobs. Okay, and if we see this soldering process, this is a manual process which is quite slow. So whatever the job is there to get ready, it takes a time. Okay, so let us see the advantages and limitations of soldering. Okay, so if we see whatever the soldering is there, okay, here you can see further the application it uses in electronics industry as I said earlier. Okay, so here the joint is there which is soldered. Okay, so soldering is normally done at a low temperature. Okay, hence there is no damage to the joining material and component. Okay, and next advantage is that because of low melting temperature, the liquid soldering of all can be easily handled. Okay, and if we see whatever the joints are there, some limitations of the solderings are the joints cannot withstand elevated temperature. And one more advantage of soldering is there, if the joint is not satisfactory, okay, so we can desolder it. Okay, so that means as we have seen during soldering process is whatever the two part you join by the soldering, if you are not satisfied with the joint you can desolder the parts. Okay, so this is the advantage of soldering. Okay, now the limitation is that the manual soldering requires a skill. Okay, and this is the what the limitation of the soldering is there. Okay, now let us see the brazing operation or brazing process. Okay, so here you can see torch is there, filler rod is there, and it is joined over here. Okay, so manual brazing is performed with a gas flame. Okay, the filler is applied separately in the form of filler rod or wire. Okay, the joining parts are whatever the joining parts are there, it is first to be cleaned and the flux is applied over here before the brazing. Okay, so this is what required in brazing processes. Now let us see the advantages and limitations of the brazing. So whatever the small assemblies are there that cannot be welded. Okay, that can those small assemblies, they are impossible to weld. These assemblies can be joined by using a brazing process. Okay, and as we know that the base metal is not heated, hence it is completely protected. And this brazing gives the strong joints which can stand a temperature of 400 to 500 degrees Celsius. And further, by choosing the correct filler material, necessary physical properties can be imparted to the joint. This is also one of the most important factor, is the advantage of brazing. And here you can see that the process, whatever the process of the brazing is there, it can be automated to obtain the high volume of production. Okay, and it can also be done manually. Okay, to fabricate or to repair a single assemblies. Okay, so if we see further over here in brazing, there are no any internal stresses or formation over here. Okay, so and further, that is whatever the thin wall tubes are there or parts of widely which is having different thicknesses, which is having different structure or having different metals can be easily joined by a brazing. Okay, so you can see over here with the brazing and braze welding. So braze welding is quite similar to brazing. Okay, but here uh, we will see the difference between the soldering, brazing, and braze welding. Okay, so if we see the principle first, that is in soldering. So in soldering, it is a joining process where coalescence is produced by heating to a suitable temperature and by using a filler material. And in brazing, where the joint is produced by a capillary action. Okay, and if we see in braze welding here, capillary action does not play the role. Simple welding helps. Okay, which is the joint is produced by the adhesion. So if we see regarding the temperature in soldering is around, you can see that 600 to 900 degrees Celsius, or we can see that 400 to 900 degrees Celsius. And in brazing, its temperature is 600 degrees Celsius to 850 degrees Celsius. And if we see in braze welding, it is less than 250 degrees Celsius. And if we see the application of soldering, brazing, and braze welding, so if we see the soldering, it uses normally to join the electronic components. And if we see the brazing is uses to join the pipe fittings. Okay. And if we see the braze welding, it is used to join the dissimilar metals. Okay, this is what we have seen about the welding. Now we will see the welding defects. Okay, so if we see the defects in the welding, the common defects in the weldings are residual stresses. Okay, and the distortion in a assembly. These are common defects. Which one? That is residual stresses and distortion. But other than these, there are some defects are there. First one, that is crack. So these are the interruptions of fracture type either in welding or in base material. It is a serious defect. Okay, the welded joint becomes weak if the crack is present. Okay, see, we are seeing the defect. Okay, and it is saying that is if the welded joint if the crack is present in a welded joint. Okay, then the welded joint becomes weak. Okay, and these welding cracks are caused by a low ductility of weld and base metals combined with high restraint during contraction. Okay, this is first defect. Second defect is the cavities. Okay, so whatever the porosity is there which is present due to the entrapped gas, okay, during solidification. So these cavities occurs. The voids are spherical or elongated, and the shrinkage voids are due to shrinkage during solidification. Okay, that means some gap is created or some cavity is created. The cavities are nothing but a welding defect. And apart from there are also many defects are there like solid inclusions, incomplete fusion, then improper shape of contour, excessive spatter. These are some defects in weldings are there. Okay, so mm, these what we have seen the different welding processes. Okay, now today we are going to stop for here. Thank you.